Alright, this is going to be part 2 of the Unit 3 notes. And we're going to pick up here with naming ionic compounds. So when you're naming ionic compounds, you want to name the cation first. And then you're going to name the anion. So the name itself does not specify the charge of the ion. And you do not specify how many ions of each type are needed to balance the charge. You're only given the names. And so we see here we have a sodium ion, we have the fluoride ion, and when we put them together, this is the formula, and this is the name, sodium fluoride. Sodium fluoride. Second example you see here, you have the magnesium ion. You have the chloride ion. The formula is MgCl2. You need 2 chloride ions to balance out the positive 2 charge. The name of this ionic compound is simply magnesium chloride. So you can see you just put the name of the cation and the anion together, and that creates the name. Now when you look at your transition metals, the ones that have multiple charges, then you need to consider a few more things. And so our example here is CuCl2. So the first thing you want to do is to determine the charge of the cation. And so when we look at this formula, CuCl2, we are not certain on the charge of copper, because remember, copper can either be +1 or +2. But when we look at the formula, the way it is written, CuCl2, we can check the charge for the chloride ion, and we see that chloride has a -1 charge. And notice there's 2 of them were needed. So that is a total of -2 when you put both chlorides together. And so that lets us know that the charge of copper had to be +2, because that's what it takes to make the overall charge of 0. So now that we know that, we can move on to step number 2. Step number 2 is to name the cation. And then follow that with the name of the anion. But the one thing that changes now is that you have to either use the systematic naming, which uses Roman numerals, or the common naming, which uses the Latin word and the appropriate ending. So the systematic name, since we decided that it was copper 2+ that was making up the formula, remember our formula was CuCl2, and so we determined that it was copper 2+. So that means that we need to use Roman numeral 2 after the word copper to indicate that it is the copper 2+ ion. When using the common name, we use CuPr is the prefix. And we would want to end it with the IC because it is the higher charge. So cupric would be that name. Then step 3, once we have decided on the naming system that we're going to use, you always write the name of the cation first. Followed by the anion. And so here are 2 ways that we could write it. We have copper, Roman numeral 2, chloride. Or using the common system, we would have cupric chloride. All right, next we want to look at how to come up with the formula if we've been given the name. how to derive the formula from the name. And so we see here we have the name of 10, Roman numeral 4, oxide, 10,4 oxide. Just a brief review of your Roman numerals in case you are wondering. Roman numeral for 1 is just I, 2 is double I, 3 is triple I, 4 is IV, 5 is just the letter V, and 6 is VI. So we typically don't go past those. So you might want to jot those down somewhere just in case you are not familiar with the Roman numeral system. So when we're given a name such as 10,4 oxide, we want to identify the cation and the anion. Remember, the cation is going to come first. For metals with variable charges, then the Roman numeral is going to help us with the charge of the cation. And so here we have 10, the symbol for 10 is SN, and we see based on the Roman numeral the charge is 4 plus. And then we have oxide, that's a letter O, and its charge is 2 minus. Okay, our next step then would be to balance the charges. We want to balance the charges. And so we see that we have a charge of +4 and a charge of -2. So we want to make sure that the overall charge is 0. So one way to approach this is by looking for the least common multiple between a 4 and a 2. So the least common multiple here would be 4. And then we'd want to ask ourselves, what do I need to multiply by 4 to get to 4? And that answer is 1. And so that leads us to just writing the SN with no subscripts because we just need one of those. Now for the oxygen, its charge is 2 minus, and so what do I have to multiply by 2 to get to 4? And that answer is 2. So I know I'm going to need 2 oxygen. So SnO2 would be the correct formula. And I derive that from the name itself. All right, our next thing to talk about is something called polyatomic ions. And so a polyatomic ion is a cation or an anion that contains more than one atom. And so that's why the name polyatomic, poly means many, many atoms. And so this chart gives you some of the more common polyatomic ions. Notice that each of them have a charge, and on this list, this is only a partial list, but in this list they're all negative charges. And if we look at the names have something in common as well. They generally end in ATE, as you see here. Carbonate, bicarbonate, acetate, nitrate. Sometimes you have an ending of ITE, as you see here, nitrite. Here's sulfite down here at the end. And occasionally you will have a polyatomic ion that ends in IDE, as in hydroxide. And so this would be a list of polyatomic ions that you want to become familiar with. These are commonly used in chemistry, in writing formulas, in writing equations. And so you will have to be able to recognize these both by name and by their formula. And just to be clear, their formula contains their charge. So carbonate is CO3 with a -2 charge. Our next slide talks about writing ionic compounds using polyatomic ions. And so we see that when we're writing formulas for ionic compounds, that contain polyatomic ion, the steps are the same that we learned earlier. The only difference is that when a cation and an anion of equal charge, well, this is not different, this is the same. When the cation and the anion have the same charge or equal charge, that means we only need one of each. And so here's a couple of examples. We have the sodium ion and we have nitrite, and the charges are the same, and so that means we just need one of each. Now notice this 2 here is part of the formula. NO2 is the formula, so you would include the 2, but you only need one NO2 to balance out the charges. So your formula is NaNO2. The same example here is barium cation with a 2+ charge and sulfate, which has a -2 charge. Notice the charges are the same, so we would only need one of each. So we have Ba, and then we have SO4. Remember, SO4 is the formula of sulfate, so we have to include the 4 there. But we're just showing we need one sulfate. Okay, when we look at the next example, when the charges are not equal, unequal, then we use the charges to determine the number of each ion that we need. And so here we have magnesium ion with its +2 charge is being combined with hydroxide, which has a -1 charge. And so if we look to balance the charges, we see we need 2 hydroxide ions. So that's why there is a subscript of 2. And notice that the polyatomic ion was put in parentheses. If you do not put this in parentheses, this is what it looks like. And this is saying that you need one O and 2 H's. And that is not the case, because remember, hydroxide's formula is OH with that minus charge. And so we have to have the parentheses here, and the 2 goes on the outside of the parentheses. So anytime you need more than one polyatomic ion, you need to use the parentheses. When you're naming ionic compounds with polyatomic ions, the rules are similar. It says you name the cation first and then the anion. In the name itself, you never specify the charge, and you never specify how many of each atom you have. But notice that the ending of our polyatomic ions are different than our other elements or other compounds that we were naming. So here you have HCO3 with a minus charge. The name of that is bicarbonate. And so you see when we put it with sodium, it becomes sodium bicarbonate. And remember, SO4 -2 charge is sulfate. So when we put it with aluminum, we have aluminum sulfate. So here you see the chemical formula, and then here is the chemical name. All right, this is just a graphic organizer, kind of summarizing everything that we've talked about for Unit 3. Some of the key ideas here, we're talking about ionic compounds. It emphasizes here that it is formed from a metal and a nonmetal, and it's composed of cations and anions. This blue side is focused on the cation, naming the cation. If it has a fixed charge, then you use the name of the element that it came from. If it has a variable charge, if there's more than one charge, then you use the name of the element along with Roman numerals to tell what the charge is for that particular ion. The common naming system uses the prefix OUS for the cation of the lesser charge, and this is prefix, but it should say suffix. It's throwing me off. You use the suffix OUS for the cation with the lesser charge, and IC for the cation with the greater charge. And then when you're naming the anion with only one element, you just simply replace the ending with the IDE suffix. And if you have an anion that is a polyatomic ion, then you're going to use the suffix that comes with that polyatomic ion. For the most of your polyatomic ions, they end in ATE, 8. There are a few that end in ITE. So that summarizes the naming and writing formulas for ionic compounds.